We will start today with one of the most important topic. That topic is called solubility product and of course ionic product. See, we have already learned that when we are talking about the solubility of ionic compounds, when we are talking about the solubility of ionic compound, the most important thing right now is there are two terms that are very important. One is of course called as the lattice energy, and the second one is nothing but it is actually called as what? Hydration energy. The first one is lattice energy, the second one is called hydration energy. Now we have already done for any ionic compound, if lattice energy is greater than hydration energy, the compound is said to be what? Insoluble. I repeat, the compound is said to be insoluble. And if hydration energy is greater than lattice energy, we used to say that the compound is always soluble in water. Now I am going to take up the most important thing. The solvent is also playing a very important part. While we are talking about the solubility, the solvent is also playing a very important part, right? See, when we are talking about water, water has a very high dielectric constant. So of course, when water has a very high dielectric constant, it will try to cleave the bond, and of course the compounds will be soluble in it. That means of course ionic compounds will be soluble in it. But if I'm talking about any non-polar solvent or any organic solvent, you will find that ionic compounds are insoluble in it, because the covalent compound or uh, covalent solvent, I will say, or to be very honest, called non-polar solvents, you'll find what will happen. The energy is not so high that can actually cleave the bond, and that's why we say that it is always insoluble in it. Now we will take up the most important thing right now. The most important thing is how to classify the substance on the basis of solubility. Now on the basis of solubility, the substances are basically classified into three categories. I repeat, on the basis of the solubility, the substances are basically divided into three categories. If I am talking about category number one, it is of course soluble salts, right? Soluble salts usually have a solubility greater than what? Their solubility is always greater than zero point 0.1. So I'll write here their solubility is greater than zero point 0.1. Now, number two. Number two is nothing but it is called which are slightly soluble. Slightly soluble. So when I'm talking about slightly soluble, there is a range for solubility, and that solubility range is nothing but it is what? Solubility is between 0.01 molar to 0.1 molar. And if I am talking about the third kind, it is nothing but it is called sparingly soluble. What is this called as? Sparingly soluble salts. So when I am talking about sparingly soluble salt, the solubility is actually the solubility is actually less than 0.01 0.01 molar. So this is basically the concept of the solubility is right now, on the basis of, as I said, that can be divided. Now let us start with an example to understand that how exactly or what is this term solubility product is. Then only I'll be able to go to what your ionic product is. But let's first start with solubility product. Now when I'm talking about solubility product, you have to actually go into the detail of this topic. You have to understand what exactly is the reaction going on inside a test tube, suppose. So what I've done, I'm going to take up a test tube. Suppose this is a test tube or a boiling tube where I have taken up a number one. Solubility product, remember beta, is always applicable for sparingly soluble salt. The first point that we have to take care is that it is always applicable for sparingly soluble salt. Sparingly soluble salt. Number two, it is always applicable for saturated solutions, or it is always applicable for saturated solution. So number one, it is always applicable for sparingly soluble salt. Number two, it is always applicable for saturated solution, or is applicable for saturated solutions. Right? Now, let us take up the example number one, which I'm going to take up right now is suppose silver chloride. See, silver chloride is one of the best example which is sparingly soluble in water. So what I'm going to do right now is suppose I'll try to add a substance. See, substances are basically divided into three types. Type number one, or the substance which is soluble in water. I repeat, if a substance is soluble in water, I repeat, if a substance is soluble in water, it's it if you keep on dissolving it, अगर आप उसे dissolve करते जाओगे, you will find that its saturation point is quite far. Actually, I have seen that few books they used to write substances are not divided into three type. They write they are divided into four type. The fourth type is which is completely insoluble in it. So if I am talking about the first kind of salt, soluble salt, that means if you keep on dissolving it, the saturation point is quite far away. But if I am talking about slightly soluble, the saturation point is nearby. But if I am talking about sparingly soluble salt, as I am talking about right now, AgCl is a sparingly soluble salt. In that case, you will find that what will happen, the saturation point is very near. So the first point here is that when I'll try to dissolve the sodium silver chloride inside the water, the first point here is that it is going to get dissolved, but before that there is one process. It will first go into aqueous solution. So I'm going to write here AgCl in aqueous first. I'll just take up the first is called dissolution. When solid will try it, or when you try to dissolve, this is called dissolution. Dissolution. I repeat what I said. When I'll try to dissolve this silver chloride AgCl, you'll find that it will try to first got, before it will try to get collected at the bottom. I said it is soluble, but you'll find that what will happen first, it goes into the solution in the form of aqueous. The reverse process is still going on, and that's called precipitation. 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 Precipitation is going on. So there are two processes which are going on simultaneously. What I said right now is when I'll try to dissolve sodium chloride inside the water, what will happen? First of all, it will show dissolution. That means it will first try to go into the aqueous solution, and then after you'll find that it will try to what? Before it is being dissociated into ions. Before it is dissociated into ions, it first goes into the aqueous solution, and then it will be converted into Ag positive in aqueous plus Cl minus in aqueous. Now, here, if you remember, I thought I have already told you that if I ask you to find out K, that is of course the constant, and I have to consider only this. It was just for the imagination I have taken up AgCl here. So AgCl, if it is the AgCl, or Ksp of AgCl has to be calculated, or K for AgCl has to be calculated. K will be equal to what? The product of the active molar concentration of Ag ions, and then of course Cl ions, divided by AgCl, of course in solid. Now, as I thought I told you, this K into AgCl, this K into AgCl in solid is actually equal to Ag positive in aqueous and Cl minus in aqueous. This is nothing but it is actually equal to, beta, that's called KSP. This term is called KSP, which is of course called as solubility product of any salt. I repeat, this is called KSP, which is actually equal to the solubility product of any salt. And of course, if you can see here, it is equal to Ag positive and Cl negative in aqueous. This is the term that I got here. Now, the point which I have to take up, this equation that I have written is only for what? Silver chloride. Suppose if I'll take up the example of, maybe suppose if I'll say barium chloride, or maybe suppose I'll say lead chloride. Lead chloride on ionization will of course give you Pb2 positive in aqueous plus twice of Cl minus in aqueous. So if you ask me what is the KSP for this, I'll say KSP will be equal to what? Active molar concentration of lead ions, active molar concentration of chloride ions, and of course raised to the power 2. In the same way, if I'll take up the example, as I said, suppose for aluminum hydroxide, which has white gelatinous PPT. I said white gelatinous PPT. You'll be getting aluminum hydroxide, aluminum 3 positive plus thrice of hydroxyl ions in aqueous. So here, if you ask me what is the KSP, I'll say it is actually equal to aluminum ions and of course the hydroxyl ion in aqueous ki power 3. In the same way, if I'll take up calcium phosphate is what? Ca3PO4 whole twice. This is the value. So that means you will be getting here calcium 2 positive, thrice of ions, plus phosphate ion PO4 3 minus ion twice. And now if I ask you KSP, because this is the splitting, that is equal to calcium to the power 2 to the power 3 and of course PO4 3 minus to the power 2. So if you ask me what is the definition of KSP, solubility product, remember beta, the solubility product of any substance, I repeat, the solubility product of an electrolyte, KSP of an electrolyte at a specific temperature, I repeat, at a specific temperature or a given temperature is equal to the product of, is equal to the product of the active molar concentration, the active molar concentration of its ions, as I said, in a saturated solution, each raised to the power, saturated solution, comma, each raised to the power equal to the number of the number of ions the number of ions that are produced on dissociation of one molecule of the electrolyte, one molecule of the electrolyte. I hope this definition part is clear to you. Now the question is, sir, it is now clear that what is basically solubility product is. ये तो क्लियर हो गया कि ये solubility product क्या होती है जी. अब सवाल उठता है कि सर, there is another term which you are talking about and that term was ionic product. What is this ionic product is? सर ये ionic product क्या term होती है? Sir, there is hardly any difference in between ionic product and solubility product, right? The important thing is ionic product is a broader term which is applicable to all the kind of solution. I repeat, it is applicable to all the kind of solution. That means whether it is saturated solution, whether it is super saturated solution, or any other. That means it is applicable at all concentration. All concentration. This is applicable at all concentration, or it is applicable to all the concentration. Right? But the most important thing is that what is this ionic product is? As the name suggests, it is always equal to the product of the concentration of ions of the electrolyte. Again, each raised to the power of their coefficient in the balanced chemical equation at any concentration. Because here we have just now said that it is equal to the product of the active molecular concentration in a saturated solution. In a saturated solution. So here we are talking about saturated solution. So when we are talking about solubility product, we talk about saturated solution. When we are talking about what? Ionic product, we always talk about what? We are talking about all the kind of solution. That means at any concentration. So we have to take up the difference between the two. Right now we are going to take up the difference between, of course, solubility product, solubility product, and of course the ionic product. We have to take up the difference between the two, ionic product. So let us start the difference between the two. As I said, the first point I'm going to take up is the definition, right? So I will include the definition here. I'll define here solubility product. Here also I'll define both of them. Second point which I have to take up right now is, as I said, this is applicable for saturated solution. This is applicable for saturated solution. And of course, when the salt is sparingly soluble, sparingly soluble, as it is sparingly soluble. And here when I am talking about, it is applicable to all the type of solutions, all the types, all the types of solutions at all concentration, at all concentration. And the most important right now is the value of solubility product is always constant for an electrolyte. Remember, at constant temperature, the most important, at constant temperature, the value is always constant. The value is always constant. Right? But here, since it is equal to the product of, I repeat, since it is equal to the product of the active molar concentration of ions, that means more the number of ions, more will be the value of ionic product. That means the value is not constant. Value is not constant. I repeat, the value is not constant and changes with concentration. With concentration. So this is the difference between the two which we have done just now. That what is the difference between the ionic product and solubility product is, right? And of course, I'll be using this concept of ionic product and solubility product for solving the numericals also, right? But now we will start with the application of solubility product. The concept of solubility product is very, very important, especially in what sense? In explaining many phenomena. Especially it is used in predicting the solubility and precipitation of the compounds in analytical chemistry. So the first part of the application of solubility product is, of course, to calculate, number one, to calculate solubility. Right? Now, if you want to calculate the solubility, the substances has been basically divided into various types, and actually we used to take up the substances in different type. Maybe the type can be, or the salt can be of type AB type, AB2 type, and so on. So we'll be discussing one by one each kind. So on the basis of which the concept of the application of solubility product can be taken up. Of course, this is applicable, as I said, for the calculation of sparingly soluble salt. As I said, it is applicable for sparingly soluble salts. So I'm going to take up the first salt, or type 1. We used to say one by one, or let's take the first type. The first kind of salt that I'm going to take up is, suppose, is of type AB type. Suppose the salt is of AB type. So when the salt is of AB type, of course it will ionize to give you what? A positive plus B negative. If you ask me, can you give me the example of the salt of type AB which are sparingly soluble? Of course, one of the best example is AgCl, as I said. Example number 2 is barium sulfate, where it is Ba2 positive and sulfate. Example number 3 is lead sulfate. Example number 4 is aluminum phosphate. So all these examples are nothing but one of the best example of this. Suppose in this case, if I'll ask you, this is X, this is X. So of course, if this is X, this is X, right? And if I ask you what is KSP, solubility product. So beta, the solubility product will be equal to the product of the active molar concentration of A positive and B negative ion. That means if I'll write KSP, it will be equal to X into X. So if you ask me what is the concentration of X, that means A positive or B negative, it is nothing but it is actually equal to under root of KSP. So this is one formula that we have to just commit to memory for the numericals. So I'll be using this formula. You can even write this as X is nothing but it is actually equal to, or X is equal to KSP to the power 1 by 2. One and only the same thing. Suppose if I want to take up the second kind of salt, अगर मैं एक second type का salt ले रहा हूँ, right? और वो second type का salt जो है वो suppose AB2 type है. So AB2 type whenever ionizes will give you, of course, what? अगर AB2 का salt ionize कर रहा है तो वो मुझे देगा A2 positive plus twice of B negative. Twice of B negative. If you ask me such kind of salt, of course, I can give you example like, maybe I can take up the example of lead chloride, PbCl2. PbCl2. I can take up the example of calcium fluoride. Such kind of salts, sparingly soluble salts, of course. Again, if this is X, so this is 2X, right? So if you ask me what is the KSP, so KSP will be equal to what? A to the power 2 positive and B negative to the power, of course, it should be B to the power 2. This is the solubility product. Now if I'll put down the value, it is X and this is 2X का whole square. So अगर ये 2X का whole square है, that means it become 4X cube. If I'm not wrong, it is 4X cube. So this is KSP. Now of course I have to find out the value of X. So my X cube will be equal to what? KSP divided by 4, or X is equal to KSP divided by 4 to the power 1 by 3. This is what I'll get. Or I can even write X is equal to KSP, and of course it is 1 by 3, right? Or 3, that is cube root of this. So This is how the second kind of salt. I can again have another example. Suppose my salt is of this type, AB3 type, and which ionizes, of course, to give me what? A3 positive plus thrice of B minus. So if this is X, this is 3X. If again I'll apply the formula, KSP comes out to be how much? A3 positive and B negative in aqueous to the power 3. So if I put down the value again, this is X, this is 3X ki power whole cube. So this is X, 3 3 are 9, 9 3 are 27. So this is 27X cube. So this become 27X fourth, right? And of course, if you again ask me to find out the value of what X, so my X comes out to be KSP divided by 27 to the power 1 by 4. This is what the answer is, or how I will be calculating the value. This is what I'll be getting. This is the answer, right? And we will be solving the numericals on the basis of this. Let's go to the second application of solubility product. As I said, it helps us to predict. It helps us to predict, of course, ionic or precipitation reaction. Ionic or precipitation reaction. Now, what I mean to say right now is, ये हमें ये बताएगा कि क्या वहां प्रेसिपिटेशन होगी किसी रिएक्शन में या नहीं होगी, राइट? Now you may ask me, sir, what is the meaning of this? The solubility product actually represent the upper limit for ionic product in a saturated solution of any sparingly soluble salt. In other word, if ionic product, I repeat, if ionic product is, that is of course the product of the concentration of the ions in the solution, exceed the value of ionic product, exceed the value of solubility product, remember beta, the precipitation will occur. This is actually of course we are talking about a sparingly soluble salt, right? So here what will happen, if the ionic product is greater than solubility product, as the name suggests, ionic product means more number of ions are present, so they will combine, resulting in the formation of what? Precipitate. So PPT formation will be seen here, or precipitate will be formed. But if the second condition is, if ionic product is less than solubility product, or solubility product is greater, so that means if solubility product is greater means the salt will be what? Soluble. So no precipitation will be seen. No precipitation or no precipitate formation is seen because the salt is soluble. Salt is soluble. So this is the second application. The third application right now is of course explaining the salting out or precipitation of soluble salt. The third is explaining salt out or precipitation of soluble salt. Precipitation of soluble salt. This is the third application, right? I will just give you an example. On passing hydrogen chloride HCl through a saturated or sodium chloride, the concentration of chloride ion will be increased. That increases the ionic product of sodium chloride and the salt will be precipitated out. What I mean to say is, suppose if I have NaCl, right? And if I'll pass HCl into it, this sodium chloride will give you Na positive plus Cl negative. This HCl will also give you what? H positive plus Cl negative. So due to this combination, you will find that sodium chloride will be precipitated or sodium chloride salt will be formed.